A very good day and selamat sejahtera to Dr. Muhammad Zaini bin Yunus. My name is Jason Tan Wai Ho, matrix number AD150265, and I'm from Section 3. Today, I would like to present about the findings of my individual project of computer programming. So, I would like to start with the introduction part. Computer programming can be applied in any field of the engineering which involve any heavy calculation. Converting all the calculation into the program and operate control by the computer has been simplified and shortened the time of the design, repair, and maintenance, and also the operation procedure. In this project, the application of the computer programming in fluid mechanics is studied. In the fluid mechanics, the characteristic of the fluid flow is focused, such as the type of the flow is. It is very important to the liquid-liquid extraction (LLE) and the other industry that use coalescer. This is because the laminar flow has slower velocities. We can increase the time of residence in the media and therefore more time for the droplet-droplet collision, which is the main function of the coalescer. Through the piping system of transferring the fluid into the coalescer, there are losses which can be called as the pressure drop, and this pressure drop is caused by the resistance to the fluid flow. Therefore, a C program is written to operate in counting the viscosity of the flow to determine the Reynolds number, which can show and determine the type of flow. Then the pumping power needed to overcome for the pressure drop in the pipeline conducting the laminar fluid flow can be obtained by getting values of Reynolds numbers and classification factors, pressure drop, and volume flow rate. Next, for the problem statement part, given the type of fluid in this study is water, with a density of 998, the viscosity of the water is determined by the viscometer. Assuming the inner cylinder is completely submerged in the fluid, the range of the value of the torque measure when the water is decreasing, the torque is in the range between 0.5 to 2.5 with the increment of 0.5. The gap between the two cylinders is 0.0015. The radius of the inner cylinder is 0.06, and the rotational speed of the inner cylinder is 90 revolutions per minute. Then the kinematic viscosity is calculated based on the viscosity that we obtained previously. Then the value is applied to the Reynolds number equation to determine the type of flow. And then in this project, the type of fluid flow is only concerned on laminar flow in pipe, which the Reynolds number is below 2,300. When the Reynolds number obtained is more than 2,300, it is no longer the laminar flow. It can be in transition or turbulence flow. And then the range of the velocity of the water flow and length of the pipe is between 1 to 3 with the increment of 1, and the diameter of the pipe is 0.1 to 0.3 with the increment of 0.1. From the information gathered or calculated, the classification factor and pressure drop and the volume flow rate are known. Using the result that we obtained from the variables of classification factor, pressure drop, volume flow rate, and Reynolds number, we can determine the pumping power needed to measure and overcome the pressure drop. So in our project, there are 6 objectives. First, which is to solve the problem related to fluid mechanics or fluid dynamics by writing a C program. Next, the program must contain 4 for loops and 2 functions. Then, to determine the viscosity of water by varying the value of torque measure, to determine the kinematic viscosity using the previous value of viscosity, to determine the Reynolds number, classification factor, pressure drop, and volume flow rate. After that, lastly, using the relevant results to determine the pumping power needed to overcome the pressure drop. Then in the methodology part, They are the methodology can be divided into two parts. First is flow chart, and the next one is program. In flow chart, there are three flow charts containing in this project, which is the main function, first subfunction, and second subfunction. In the main function, there are one for loop, which is from the range t from 0.5 to 2.5 with the increment of 0.1, and then with the increment of 0.5, and then from the for loops we obtain the viscosity, which is u, and then and then the value of u is transferred to the next first subfunction, and from this first subfunction, if you the u measured, the u calculated is inserted in this function to calculate the kinematic viscosity, which is the big V, capital V, and then from this capital V, and then the program is transferred into the next second subfunction. And in the second subfunction, there are three for loops, which in the range of velocity of the fluid flow, the diameter of the pipe, and the length of the pipe. And then when the after that, in this for loop, and then we calculate the Reynolds number. From this Reynolds number, there is a if condition, if else condition. When the Reynolds number is below 2300, the calculation will further perform, and to calculate dusty friction factor, the pressure drop, the flow rate, and the power needed to the pumping power. But if the Reynolds number obtained is more than 2300, the program will display error and showing that this flow is transition or turbulence. Next, in the result part, this is the result that we obtained from the program C program, and we can see that the torque measure is 0.5 as the first input, and then the viscosity calculated is 0.146549. Kinematic viscosity is 0.000147. Then and then it transfer into the second subfunction, and then it perform the three for loops looping, and then it calculated for several times. And from this reading, we can see that the dusty friction factors values, the values of pressure drop, the value of volume flow rate, and the values of pumping power. And then for the next for the looping in the main function, when the torque is measured equals to 1, the viscosity changes, and the kinematic viscosity also changes. And then the looping of the Reynolds number is the looping for the second subfunction is repeated with the new viscosity, kinematic viscosity, and then to calculate the new Reynolds number, and then to perform and determine whether the Reynolds number is below 2300, and then to determine if the Reynolds number is below 2300, the dusty friction factor is calculated, the pressure drop, the volume flow rate, and the pumping power is calculated. The value is calculated. But then, as we can see that when the Reynolds number is calculated is more than 2300, it will no longer perform the further calculation, and it will show the error and determine that the flow is transitional or turbulent. Furthermore, the calculation obtained from the program C is the same as the result that calculated accordingly by using the formulation of viscosity, kinematic viscosity, Reynolds number, dusty friction factor, pressure drop, volume flow rate, and pumping power. This shows the correctness of the C program. So as the conclusion, all the objectives stated are achieved in this project, and for the result obtained, we can see the The relationship between the pumping power and the pressure drop can be deduced that when the pressure drop increase, the pumping power increase. That's all from me and my presentation. Thank you.